Today, let us look at the sum of n terms of an arithmetic progression. Let us look at a generic AP where the first term is A and common difference is D. Let us write down the terms A1, A2, A3 so on till AN in terms of A and D. Now the sum of the terms of this arithmetic progression could be denoted as A1 plus A2 plus A3 and so on plus AN-1 plus AN. Once again, let us write this down but in the reverse order. So now the last term becomes the first term and the progression carries out in reverse. Now let us add these two equations. So on the left hand side we get 2 times the sum, and on the right hand side the first terms of both the equations add up to 2a plus n minus 1 times d. Similarly, the second term of both the equations add up to 2a plus n minus 1 times d. In fact, every such term adds up to 2a plus n minus 1 times d. Simplifying, we could write the right hand side as the term 2a plus n minus 1 times d is appearing n times. Dividing both sides by 2, we get the sum of n terms as n by 2 times 2a plus n minus 1 times d. Or we could also write this as n by 2 times a plus an. That is first term plus the last term. Let us look at a few problems. Find the sum of the first 40 positive integers divisible by 6. Now we are looking at the first 40 positive integers, so n is equal to 40. Now we are looking at numbers divisible by 6, so the first term of such a progression would be 6 itself. And the common difference would be 6 as well, because to find every next multiple of 6 we would be adding 6. You could also write down the first few multiples of 6 and figure out that the common difference is equal to 6. Alright, now we have to find the sum, so let us write down the formula for sum of n terms and substitute the values for a, d and n. Now we simplified the brackets by doing 40 minus 1 equals 39 and then multiplying it with 6. There was another way. You could do 40 times 6 minus 1 times 6. It would fetch you the same result. Let us look at another problem. Find the sum of first 51 terms of an AP whose second and third terms are 14 and 18 respectively. Let us write down everything that we are given. So we are looking at first 51 terms. So n is equal to 51. Now the second and third terms, that is A2 and A3, are given as 14 and 18. And we have to find the sum of first 51 terms. So we know that n equals 51, but we do not know the values of a and d. Now recall that nth term of an AP can be represented as a plus n minus 1 times d. Let us apply this formula to A2 and A3 both. So we get two equations and two variables. Let us use the elimination method to find d is equal to 4. We can put this value of d in one of the equations and find out a is equal to 10. Now we can apply the formula for sum of n terms. Let us substitute the values to find that the sum of first 51 terms of this AP is 5610. Let us look at another problem. A sum of 700 rupees is to be used to give 7 cash prizes to students of a school. If each prize is 20 rupees less than its preceding prize, find the value of each of the prizes. So we're given sum as 700. We also know that n is equal to 7. We're also given that each successive prize is 20 rupees less than its preceding prize, which means that the common difference is equal to minus 20. We are going to subtract 20 to get the next prize. Now we have to find the value of each of the prizes, which means that we need to figure out the AP, which also means that we need to find out A. We would need A and D to figure out the AP. Now let us look at the sum of 7 terms. Let us apply the formula for sum of n terms and substitute the given values. Since A is the only unknown, this equation gives us A equals 160. Now we know the values for A and D, so we can easily figure out the arithmetic progression. The first term is 160. The second term would be 160 plus the common difference, which is minus 20. This gives us 140. The next term would be 140 minus 20, and so on. Note that we only have to find out 7 cash prizes, so we shall stop at the 7th term.